Emmanuel. Ah, I see.
We're using ANSYS today.
Yep. Yes, we are.
No notes, just ANSYS.
Just ANSYS. Yep.
Okay, cool. Thank you.
Yeah, so you will need to download a CAD file. So if you go to the Canvas site and then go to assignments, you should see that I've activated ANSYS activity 2. And then you can download the CAD file here. And so this first link right here is the PDF, which has all the instructions, and then the CAD file is the second link.
So it's a SolidWorks file, right?
It's actually a parasolid file, so it should be .x_t. I think SolidWorks can save in that format, but I think it's not the most standard one. But yeah, parasolid. Where this part was given to me in parasolid, so that's what we're going to use.
Oh, okay. Because I'm trying to open it, but it's not letting me.
Okay, we'll open it up in ANSYS later.
Okay, so
Yeah,
okay,
this
all right,
particular part might have been created outside of SolidWorks, or maybe in a different software.
okay,
And so I don't know if you can always convert Parasolid into SolidWorks, but you can definitely go from SolidWorks to Parasolid. That's for sure.
all right, cool, thanks.
Mhm. If you guys are just joining us, we're going to be doing an ANSYS activity today. So if you can open up ANSYS Workbench, then you can go ahead and get started with that. I've also posted the activity on Canvas. And so if you go to Canvas and then you go to the assignments page, you should be able to download two things. And so first thing you can download here is the PDF, which has all of the instructions. And then there's also a CAD file that I want you to download as well, which you can do from the second link in the activity. We'll get started at 4 o'clock. If you guys are just tuning in, we're going to be doing our second ANSYS activity today. And so if you can start up ANSYS Workbench, that would be a good idea. And I've also posted the assignment on Canvas. And so if you go to the assignments page on Canvas, you should be able to click on ANSYS Activity 2, Bike Crank. And from here, you can download two files. So you can download the PDF, which has all of the instructions and everything you need to do to complete the activity, and also the CAD file that you're going to be working with right here. Right? So if you can download those two things and start up ANSYS, then you'll be set to go once we begin the lecture. Okay, it's 4 o'clock, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Doing well, thank you. How are you doing?
Good, good. All right, so it's the day that I get asked about literally every single week. So it's our second ANSYS activity, right? And so we're going to be, starting today. We'll be getting a steady diet of ANSYS activities. So I have one planned every other week up until kind of near the end, when that's when we'll shift to you guys focusing more on your final projects. Okay. All right, so today we're going to be doing an ANSYS simulation on a bike crank, and so we're going to be doing a finite element simulation on that. And so this will introduce several. This is going to build upon a lot of the features that we learned on our first activity, but also we'll also learn a lot of new things today too. Especially, I think most critically, we'll learn how to import a CAD file, right? And so this is typically how you would normally work with ANSYS, is that you Usually you're going to create your CAD or you're going to create your geometry in a separate program. Most commonly for this is SolidWorks, just because that's the one that everyone tends to use. And then from there, you can save your part. Usually you have to save it in a certain file format, and then you can then load that into ANSYS and then kind of do everything that we've done from there, okay? All right, and so just as I was telling people before the lecture today, all the files for the ANSYS activity today is posted on Canvas. And so the way that you're going to reach it is you're going to go, let me click student view for a second. Okay. And so you're going to go to our Canvas site, and then you're going to click on assignments. And then you're going to go to ANSYS activity 2, which is the bike crank. Right? And then from here, you're going to download these two files. And so the first file is the PDF. And so that's something that you can check later on as you're finishing up the activity. But most critically, I need you to download the CAD file, which I prepared for you right here. And that one's going to be the CAD file that we're going to be working with, okay? And then while you're doing that, while you're downloading that, also make sure to start up ANSYS Workbench, and we're going to start just from right here, okay? All right, so are there any questions I can answer before we get started today? Okay. All right, so let's go ahead and get started. And so, hopefully you've had a chance to download the CAD file, and let's go ahead and open up ANSYS, right? And so here we have ANSYS Workbench. So we have a brand new project. And so this is kind of where we started last time, okay? And just like we did last time, we're going to be running a structural simulation. So just to kind of remind you how to do that, you're going to go to the toolbox on the left-hand side, and then you're going to go to static structural right here, and then you're going to click and drag that into the problem schematic, which is this area right here. Okay. And then once you do that, you'll have this menu that appears right here. Okay. And if you remember from our first ANSYS activity, this basically kind of shows the outline of what we need to accomplish, right? And so first thing we're going to do today is we're going to establish material properties. And so we're going to do that in this engineering data tab right here. Next, we're going to import our geometry. And so our geometry is already made for us here. So there's nothing for us to create this time. And so we can just kind of simply load that in as is, okay? Then we'll move on to ANSYS Mechanical, where we're going to mesh the geometry and apply our boundary conditions. And then we'll, of course, solve our finite element solution and then look at the results, okay?
Professor, what button do you hit to get analysis systems to pop up?
Yours is empty right now?
I only have the component systems and the ACT.
Okay, you might need to reinstall ANSYS because it's it might be, or let me see. Can you try?
Same for a couple people.
Okay, a couple people are having the same thing.
Yeah, it's the same for me as well.
Same for me too.
Okay, huh? Oh, I see. Okay, so John is saying at the bottom there's a button called View All. Do you guys see that button?
Are we doing static structural again?
We are doing static structural, correct. Mm-hmm. Okay, yeah, so if you're not seeing this analysis systems toolbox here, go to the bottom left right here and click View All. And then from here, see if you can find static structural like this. And then from here, you can go ahead and click and drag this into the workspace, I'm presuming. Or make sure it's checkmarked right here. Yeah. And so once static structural is checkmarked, you can then click and drag it into the main workspace.
Professor?
Yeah, what's up?
When I'm trying to do this, on my toolbox on the left-hand side, all I have is component systems and ACT.
Yeah. Several people seem to be having that as well. So if you're having that issue, go down to the bottom.
I'm like kind of behind. Is that what you guys were just talking about?
Yeah. So you're going to want to click on this button right here called View All or Customize. And then from here, hopefully you should see all the analysis systems right here. For some reason, maybe your guys is unchecked, but you want to go to static structure right here and make sure that this is enabled and checked right here. And then once it's enabled, you can click and drag this into the problem schematic. Yeah.
Where's View All?
It's on the very bottom left of the screen.
I don't know what's happening, but I'm trying to click and drag and it's not doing.
Yeah, it's not letting me click and drag it either.
It's I think you need to click and drag it from the toolbox over here on the left. So make sure it's enabled right here from the toolbox customization, And then once it's enabled, then on the very left-hand side, then you can click and drag static structural into the problem schematic.
When we enable it, it just doesn't pop up in the toolbox.
Oh, it doesn't show up in the toolbox.
No.
Huh, that's weird. I explicitly went today and I downloaded, I uninstalled all of the previous versions of ANSYS that I have, and this is the most recent one. So this is 2021 R1, correct? That's the one you guys are working with?
Yeah.
Yes.
Okay. Okay. Okay, that's very strange.
Would it have to do with that license thing that we had before, the 25-day thing?
It could be. So it could be that and I didn't see that error when I tried to reinstall ANSYS today. So you guys could try and try reinstalling ANSYS after or you can kind of keep along with the class, and if and during that time you can reinstall ANSYS. That might solve the issue, because I can't think of unfortunately I didn't come across that same issue, so I'm not sure exactly what to or what advice to give you, but you can try reinstalling, because I just installed this version of ANSYS today, and so hopefully if you kind of download what's on the website right now and then install it, then you should be able to get that again. Yeah. Yeah, how very strange.
We open Workbench, right? That's
yes.
the one that.
Yes, you're going to open up ANSYS Workbench.
Are they going to allow us to install it again if, like, this was a trial and it expired? Like,
oh, can you say that again?
So as I understand it, the one that we downloaded was a trial, and I think it might have expired or something.
Oh, okay,
they,
I see.
Like, allow us to download.
Okay, let me show you how I downloaded it then. So I usually open up Google and I type in download ANSYS student. And then you want to go to this page right here where you want to make sure the URL is ansys.com/academic/free student products. And then you want to download ANSYS student, this one in the middle right here. And then from there, you can download this ANSYS student 2021 R1. And so this will give you the student version, which which should at least be good for a year. And then then you can kind of use it just like we did in the class. Yeah.
Do we have to uninstall the other version that we already have, or can we just?
That's probably going to be the safest, just to make sure that you that there's no conflicts with the licenses or anything like that. Yeah. Yeah, sorry about that, everyone. Yeah, hopefully once you download this ANSYS student, then most of these issues will go away. But probably you guys are right. Probably the what happened before was the license. I guess you guys downloaded a trial version of, maybe you guys click this free trials right here. And then probably that one expired. But what we want is the ANSYS student one. So the ANSYS student will give you, I think, unlimited access for about a year. It's just the you'll be limited in how many elements that you can use for the simulation. But for this class, that limitation is going to be okay, because we're not going to do anything too heavy in ANSYS.
Oh, what is the name of the thing on the uninstall? Because it's just there's no like Workbench or ANSYS under the uninstall.
When you go to the start menu and you click here, there's no, you don't see this uninstall right here.
Oh, you're just doing that. Okay.
Yeah. So if you can find uninstall within your ANSYS Workbench, that should work. Yeah. Okay. So I guess for those of you who have to kind of reinstall, then I guess just kind of install that in the background and just kind of keep up in the or just kind of catch up when you get that installed. Okay. Sorry, let me catch up on the chat because it wasn't notifying me when the chat was there. Yeah. Okay. Yeah. So for those of you who are having issues with the static structural not showing up, just go ahead and uninstall ANSYS and then make sure you download the student one. And so don't go to free trials. You want to download the ANSYS student 2021 R1. Okay. And that's the that's the one that I'm using. Okay. Okay. All right, and so after you drag static structural into the workspace right here, the first thing we're going to do is we're going to specify a custom material property. Okay. All right, and so to do that, we're going to double click on engineering data right here. Okay. And so if you remember, we saw this during our first ANSYS activity where we double click that, and then we didn't really do much, but we just kind of looked at the material properties that were already kind of installed. And so right now, where you guys, where I want to kind of highlight the attention to was kind of this middle of the screen right here, which shows you, what materials that we have currently loaded, right? And so right now we only have one material, and that's structural steel. And so structural steel is kind of the default material within ANSYS, and it has all the properties that are filled in. Okay. But for this particular project, what I want you guys to do is I want you guys to run a simulation with the material properties being aluminum instead of structural steel, right? And so right now we don't have aluminum here, and so we can go ahead and add it custom.
Yes, sir.
Oh yeah, what's up?
So if you go to the very, very bottom of ANSYS on the side, from where you pulled out static structure, it says view all on the very bottom.
Yeah.
I think it might pop up there.
Oh yeah. We were looking at this earlier, but for some people, even when you enabled it, they said they still had issues with dragging it in. Yeah, thanks though. Yeah, I didn't know about that view all button too, so that's good for future. And I can see here that there's actually a lot of there's a lot of other analysis modes here that aren't showing up here. So this might be a good summer project for me to look and see what's available here and develop more activities. Okay, and so what we're going to do is we're going to now we're back in engineering data right here, and we want to add a new material. All right, and so to add a new material, we're going to click on this kind of empty text box right here, and you can kind of see the tooltip here says click here to add new material. Okay. And the first thing we're going to do is we're going to give this material a name. Okay. And since we're going to run the simulation with aluminum 6061 T6, let's go ahead and name it that. Okay. But you can of course label it whatever you want, but usually it's helpful to name your materials after what they actually are, right? So give your things helpful names. Okay.
Professor?
Yeah, what's up?
Just really quick, after you clicked ANSYS student, there's nothing extra you need to do. Just go down to download ANSYS student 2021R, because when I did that the last time, that's when we got the I guess the trial version or something. So I did that before, so I'm not sure.
Oh, maybe the link was broken that day, but maybe they fixed it since then. Because I literally just downloaded this one today, and this is kind of what I'm seeing here. So maybe back then the link was just broken for the site, was just having issues, and so hopefully now this is the correct one to download. Yeah. Okay, and so. Now that we've created our aluminum 6061, you can see there's this question mark next to it. And what that question mark tells us is that right now this material is nothing. And so we haven't really assigned any properties to it. We've kind of just created a container for it. And so we need to actually fill this in with the appropriate material properties. Okay. All right. And so you can see here from the left-hand side on the toolbox, there's a lot of different materials that we can add, or a lot of different properties that we can add to this material. Depending on the kind of simulation that you want to run. And so, at this point, ANSYS is a very sophisticated software, so you can do a lot of different kinds of simulations. And so, we're going to ignore the vast majority of options here, and we're going to stick to the ones that we just need for a static structural simulation, right? And so to do that, we're going to use, we're going to open up this menu here for linear elastic, and then we're going to click and drag this isotropic elasticity into this workspace right here, okay? Because isotropic elasticity will allow us to specify the Young's modulus, and that's going to fill in basically everything else that we need for us, right? We need to specify Young's modulus, and we need to specify Poisson's ratio. Okay. All right, and so the first thing, let's specify the Young's modulus, and you can see that the Young's modulus is highlighted by a yellow box right here. And this is typically what ANSYS will tell you. This is what ANSYS will use when it tells you you need to fill in something there. Right? And so if we go to the problem document, we can see that the Young's modulus that we need to specify is 1 times 10 to the 7th PSI. Okay, and so to change this unit to PSI, all we have to do is click on this down arrow, and then select the option here for PSI. And now this will allow us to specify the Young's modulus in PSI. And so you might have to double click this this window here just to make sure that the this text thing shows up. And I'm just going to specify as 1E7, which will be 1 times 10 to the 7th. Okay. And then our Poisson's ratio is going to be 0.33. And so once you specify those properties, you can see it's going to fill out all the other ones. So it'll fill out bulk modulus and also shear modulus here. And then from here, we're good to go, right? And so, just to kind of recap, there's lots of different material properties here that you can specify for your material, but you don't have to specify all of them. And actually, for a lot of these, a lot of them are really hard to find, for a lot of, materials, even if you look at the material data sheet. And so for a static structural simulation, which is, what the majority of what we're going to be running in this class, the only thing that you need to add is isotropic elasticity. Okay? And this, of course, makes the assumption that your material is isotropic, which for a metal is a pretty good, pretty good approximation. But for some of your final projects, I know you guys might be working with interesting materials. I know for sure some of you are going to be working with 3D printed stuff, and so for that you might have to use a different kind of elastic model here. So you might try either an orthotropic material or an anisotropic material. But for now, we're just going to assume it's isotropic just to keep it simple. Okay. All right. So any questions on this so far?
Professor, I forgot, how did you get to this page with the definition of materials?
Sure. Yeah, so to get to this page, you're going to go back to kind of the problem schematic here, and you're going to double click on engineering data.
Gotcha. Thank you.
Yeah. Yeah, so it's a little bit jarring because you double click this and it kind of changes your whole menu. But and then you can click these tabs up here to kind of switch in between the different views. Mm-hmm. All right. Any other questions on this part?
Is there anything that you need to save after you do that?
Yeah, you can save. And so to save your project, you want to do it from the workbench right here, and then you can click Save Project, and then you can kind of give your project.
Like you have your tab still open. Does it still automatically save to the main project itself even after entering that in, or do you have to do you have to click one of those check boxes next to aluminum and structural steel to set it? Like what do you exactly do to set the?
I think it's as soon as you enter the properties here, it kind of updates with the program, and so there's nothing to really save because it's all kind of one fluid program. Yeah.
So do you then click aluminum, or then do you click structural steel, or how does that work?
I'll show you later. So right now we're kind of just creating our data sheet for the materials that we're going to use, and then later on once we're running the simulation, there we can assign the material. So the reason it's like this is because if you're doing like a finite element simulation on an assembly and you have several different parts made of different materials, here you would basically define all the materials that that you're going to use in your simulation, and then later on once you're doing the meshing and stuff like that, then you can say this part is aluminum, this part is steel, this part is copper, and things like that. But here we're just kind of listing out everything that we're going to be using. Mm-hmm.
And then how do you get to where it says outline of schematic? Mine only says properties of project schematic. Like that, the top half of that isn't even showing for me.
Oh, this top half's not showing where I'm
correct. Correct.
Let me see. Maybe go to view right here and then click make sure you have outline check mark right here.
Oh, cool.
Yeah, if you're not seeing a certain window that I'm seeing, check the first thing to check is just the view button here, and then just make sure that everything here is check marked. Yeah.
And then is there anything I need to update? Because right now my outline says no data.
I think that's okay. I'm surprised that structural steel is not there, but that's fine. We're not going to use structural steel. Okay. And so do you have a button here to click to add a new material?
No, it says outline no data, and it's just an empty. It's like 2 empty cells.
Oh, it's interesting. This is very new. So I've taught this class several times, and you guys have already come up with a lot of issues that I've never ever seen before in ANSYS. Let's see. So there's absolutely nothing that you can click here to add a material or anything. Try right clicking and see if you can add something.
Expand all, collapse all, but that does nothing.
Okay. Huh. Let me why don't you hold on to that for now, and then let me come back. But I want to make sure that everyone. It won't take me long to kind of go through all the other instructions, because we did most of the meshing and stuff before. But let me go through the instructions first, and then I'll come visit you guys individually.
Awesome, thank you.
Mm-hmm. Okay, and so now that we've specified the material properties, now we need to import our geometry. Okay. And so if you remember from what we did in ANSYS activity 1, what we did at this point was we basically constructed the geometry from scratch. And so we used a CAD software that was built in within ANSYS called Design Modeler to kind of draw our geometry. And so that's fine. And so that's if your part is relatively simple and you want to just keep it all within the same program, you can definitely do that. But what's more common, especially more common in professional practice, is that you would use kind of a more sophisticated CAD program like SolidWorks to build your model, and then import that into ANSYS. Okay. And so let's go over how do you actually import these kinds of external models. All right. So you're going to right-click Geometry here, and then you're going to go to this menu right here called Import. And then once you highlight this Import button, then you're going to click Browse. Okay? And this will basically open up a file explorer on your computer where you can go find the files. Okay. Okay. And so at the beginning of class today, I asked you guys to download the CAD file from the Canvas site, right? And so if you download that file, you should see that it's called crank_assembly.x_t. Okay. And so let's go ahead and find that file. And so for me, that file was in this folder because I was, testing it earlier. But you have to you're going to have to navigate to the location on your computer where you downloaded that file. And then once you found it, you can basically just double click it, and then that will load your geometry in just like that. Okay. And if you did it correctly, then the geometry, there should be a green check mark next to it, and then you should see a P right next to geometry. And so that P is just unique for this particular case because this geometry file that I gave you was a Parasolid file, and so that P there is for Parasolid. Okay. Any questions on importing the geometry so far?
So you just right-click, import geometry, browse, find it, click it, and you're just done. You don't have to do anything else.
Yep. Mm-hmm. And then once your geometry is loaded, then what you can do is you can double click on model right here, and this will open up ANSYS Mechanical, which is where we're gonna do all the meshing and the boundary conditions and all that stuff. Yeah.
Professor, what type of models does it accept? Like, will it accept STLs, step files, all that stuff, or no?
Yeah. So that's a good question. So the typical formats that I use are either Parasolid, step files work great. And IGS files work really well.
IGS, okay.
Yeah. And so if you're coming from SolidWorks, I think what people typically do is they convert the SolidWorks part to a step file or an IGS, and then they'll import that directly into ANSYS. Yeah. Okay. And so if you double click on model here for on your ANSYS workbench, you should come to this screen right here, which shows your bike crank. Right. So this is going to be the geometry for our model. For our simulation for this activity. Okay. All right. And so now that we're here, we're ready to start working with the geometry. So actually, Alex, to answer your question, now is where we're going to assign the material properties to this bike crank. Okay. All right. So, but before we do that, you should see that this bike crank that I gave you is actually an assembly of 3 different parts. Okay. And so first part is we have the bike crank itself. And so this is the main body of the bike crank. And so this is what we're going to do our analysis on. The next part is this kind of bearing that's in here to kind of make sure the pedal fits into the crank. And then we have this little rod out that comes out, and this is the pedal for our bike crank. Okay. And so visually, think this is basically like a crank that you would find on a bicycle. And so this is where you would put your foot would go here and you would push down, and then your bicycle would go forward. And so for this particular simulation, we're only really interested in just the crank. And so we want to perform just a stress analysis we're going to perform just a stress analysis on that crank, basically. And so we don't need the pedal, and we don't need this little, little housing right here. And so this is fairly common too, because a lot of times, you're going to create your part in SolidWorks, but for your finite element simulation, maybe you're only interested in the simulation for just a tiny part of it. And so in ANSYS, what you can do is you can suppress certain parts of your model to make sure that they're not going to be part of the final simulation. Okay, so let's go over how to suppress different parts. Okay? And so first thing to do, let's suppress this pedal right here. And so under the geometry tab on the left-hand side, if you haven't expanded that list, go ahead and expand that. And you're going to right-click on pedal right here, and you're going to click suppress body. Okay. And then once you suppress the body, you can see that it goes away. Right? And so we're going to do the same thing for this little housing right here, because we don't really need it. Okay. So let's go ahead and right-click this, and then click on suppress body. Okay. Make sure you click suppress. So I know that there's a button here for hide. But hiding is not the same thing as suppressing. So suppressing will basically kind of remove it altogether from the simulation. If you hide it, what that's going to do is it's going to, you won't be able to see it in your model anymore, but it's technically still going to be part of the simulation. So your ANSYS will still try to mesh it, and it will still try to compute things for it. Okay? And so we don't want to hide it. We don't want to simply hide it. We want to actually suppress it, so it's actually not going to be part of our simulation. Okay. And so you make sure to click suppress body right here. Okay. And so once you're done with that, you should be left with just simply this, just the bike crank, right? With the pedal and the little, attachment suppressed. Okay. All right. Any questions on this so far? Okay.
You're going to set the material in this after you suppress?
Yes, yes. Or
okay.
you can set the material first if you want, but either order that you want. But
I missed it. You just go to materials again and right click it, right? Or
yeah. So to set the material, you can click this bike crank right here.
You don't go down to the material, the materials subfolder, or no?
No. So this material subfolder here will just tell you which materials that you have available. But you need to now assign a material to the particular parts in your geometry. Yeah.
Oh, okay. Okay.
Yeah. So to do that, you're going to go under geometry and then left click on your part right here. And then you're going to go now to this bottom left part of the menu right here, where this is going to be the properties for this part of the model. And so from here, you can see that there's a line right here for the material. And right now it's assigned to structural steel. And so what you're going to do is you're going to click the arrow right here. And then you're going to see all the materials that you have available to you. Okay. And so, from earlier in the tutorial, you can see that we've created this aluminum 6061 T6. Okay. And so let's go ahead and click that. And then now our material is assigned as that aluminum. Okay. Right. And so, just like I mentioned before too, we're like, say that we want to, run this simulation with this entire assembly, and say that we know that the pedal was made of a different material than the crank. And so, with this feature in ANSYS, you can assign different material properties to different parts of your model, which is usually pretty common, because a lot of times when you have an assembly like this, each different part of that assembly is going to be created with a different material. Okay, and so before you move on to the meshing and the boundary conditions, make sure that you assign the appropriate aluminum material properties to this. Okay, any questions on this so far?
So far we just suppressed components. Haven't really added anything yet.
Yeah. So we just suppressed the components, and we assigned a material property of aluminum to our bike crank.
Okay, yeah. Cool.
Mm-hmm. Okay. All right. And so from here, that's all basically the new stuff for this activity. And so now we're going to get into a lot of the things that we did for ANSYS activity 1. Okay. And so the first thing we need to do is we need to put a mesh on this guy, okay? And so you can see here that there's a little lightning bolt next to the mesh. So that tells us, we need to do something there. And so we can go ahead and generate a default mesh. And so, without applying any settings, we can right click mesh right here and click generate mesh. Okay. And so if you do that, you can see that our geometry is meshed right here, okay? And you can see this is a fairly coarse mesh. And so there's actually very few elements here. And in fact, these elements are tetrahedral, okay? And so if you remember, from the first ANSYS activity, there are two options for shapes that you can pick for a 2D simulation. And so for 2D simulation, you can basically pick rectangles and you can pick triangles, right? And so for that case, it didn't make that big a difference. But here, we're doing a 3D simulation. We have different options for our shapes, okay? And so let me show you how to control the shape of your finite elements, right? And so you're going to right-click mesh right here. You're going to click insert. And then you're going to click method right here, okay? And then that's going to create this automatic method object, okay? And then just like we did before, what you're going to do is you're going to select the geometry where you want to apply this this meshing setting. Oh, does someone have a question?
What did you do to add the automatic method again? Can you just?
Yeah. So I right-click mesh and I clicked insert, and then I clicked method right here.
Oh, okay. Then it does automatic.
Yes. Yeah.
Okay.
Mm-hmm.
Automatic method. Okay.
Yeah. Because right now we haven't added anything, so it just calls it automatic method because it's kind of determining everything automatically. Mm-hmm. Okay. And so let's go ahead and select this geometry here and specify it for this. So make sure the entire bike crank here is highlighted in green, and then go ahead and click apply. Okay. Right. And so that's going to specify this this body. And from here we can select the shape. Okay. All right. And so, make sure you have automatic method selected right here on the top left of the screen. And then on the bottom left here, you can select the type of shape that you can do. Okay. And so right now it's just choosing it automatically, but you can force it to choose certain different shapes. Okay. And you can see in 3D, I don't know if you remember in our first activity, but we only had just a couple options here. So it's just either basically quadrilaterals and triangles. But from here, we have a lot of different options just because, 3D meshing is a lot more complicated than 2D, right? And so, but the two main options I want you guys to keep in mind are one is tetrahedrons. And so tetrahedrons are basically what you're seeing now. And so tetrahedrons are kind of like the 3D equivalent of triangles, okay? And so if you're curious what a tetrahedron looks like in 3D, it's basically a four-sided pyramid. Okay, and so that's your D4 for any Dungeons and Dragons fans out there. Okay, and so what ANSYS is doing right now is basically filling up the space of your geometry with these kind of four-sided triangles, four-sided pyramids. Right. So visually, you only see the triangles because you only see what's on the surface. But if you can imagine, these triangles kind of extend into the body, and they're basically four-sided pyramids. Okay? And so just to I'll let you choose for this activity. And so you can either pick tetrahedrons or hexes. End of the day, for this one, it doesn't really matter. But try out the different ones and see what they look like. Okay.
Question.
Yep. What's up?
So let's say you're out in the industry, which one is more commonly used or more beneficial, would you say, or have you heard?
Yeah. We'll get to that kind of later in the class. And so, there are factors that you can choose that affect, which element shape that you choose.
Okay.
Yeah, but kind of in a nutshell, a hex is basically a brick. You can kind of think it. So it looks like a box. And so usually you want to pick those for geometries that kind of already look like a box. And so for geometries with kind of like straight edges and sharp corners and things like that. Mm-hmm. For tetrahedrons, tetrahedrons are great for objects that have a lot of curves to them. Right?
Okay. And
so for tetrahedrons have this really nice property in that they can fill any 3D space exactly. And so if you have kind of a very complicated, very twisty geometry, tetrahedrons are kind of your way to go for that.
So that one basically fills in the gaps.
Exactly. Right.
Okay.
Yeah. So for this kind of object, where it's kind of, you can see it's kind of curvy. My guess would be tetrahedrons would be, you know, a little bit more efficient here. But the thing with tetrahedrons is that because, you know, because a four-sided pyramid is not as space filling as a brick, basically, what tends to happen with tetrahedrons is that you end up with a lot of elements, and sometimes that's a consideration where you can't really, you know, it depends on the constraints of your geometry too. But we'll talk about this a lot more later in the class once we start getting to a lot more of the practical finite element stuff. Yeah. All right. But just to kind of show you a difference, I'm going to pick hexes for this, just to kind of show you the difference between that. Okay. Okay. Let me check the chat real quick. Okay. All right. And so the other setting that we're going to set here is the element order, right? And so we actually talked about this briefly earlier this week. So remember when we were solving for the solution to the weak form of our boundary value problem, you know, we had to assume a form of the solution. Right? And so for that particular problem, for that particular example that we did, we assumed a quadratic function. And so when you pick a quadratic order here, that's basically, you know, doing the same thing. And, you know, just like the element shape, you know, we're going to talk about this a lot more later on in the class about, you know, how do you, you know, when do you pick linear, when do you pick quadratic, and what are kind of the considerations for that. But for this particular activity, quadratic just is going to end up just working better because it's a static structural simulation. And for structural simulations, typically you're going to choose quadratic for these just because they help you avoid some more tricky issues. Okay. And so, you know, just for demonstration, you know, I'm going to show you what a hex dominant quadratic mesh looks like. But for this activity, you know, I kind of leave it up to you. So you can kind of choose, you know, which one that you want. Okay. Okay. And so from that, now that we've set the size, we set the shape of the element and the element order. Now we can set the size of the element. Okay. And so I think last time someone pointed out that you can change the size of the element just by highlighting mesh right here, and you can, you know, change the size right here. But typically what I like to do is I like to create an explicit sizing object, kind of like the same as what we did for the method object. And this will basically kind of, it kind of just shows up a little bit nicer in terms of the settings. So then you have kind of a thing that you can click on the side to basically set the size. But you know, if you prefer to kind of set the size down here, that's fine too. But this is kind of where I'm going to do it. Okay. And so just like we did for the hex dominant method, we're going to right click on mesh. We're going to go to insert and then going to click sizing right here. Okay. And then just like we did for the automatic method, we're going to click our geometry, make sure it's highlighted all green, click OK, right? And then we're going to set the size of the element, right? And so right now the element size is basically, what is this? I think it's 1 centimeter. Let me change the units just to kind of see. Okay. Yeah, so the element size right now is 1.1 centimeters. And so let me take this down. Let me set this to 0.5 centimeters just to make the mesh a little bit more fine. Because right now this mesh is a little bit coarse because you can kind of see that it's really kind of pixelated from here. Okay. And so now that we've specified the method and the sizing, we can go ahead and generate the mesh. Allow ANSYS access to all your personal data. It's no big deal. And then what you'll see here is now we have a much more refined mesh. Okay. Professor? And so for question? Go ahead.
What was the size of your elements again?
So I picked 0.5 centimeters. Okay. Mm-hmm. Yeah. And so you can see from the mesh that shows up here that we have we have much more elements. So the elements are much smaller, and the element sizes or the element shapes now are mostly these squares, right? And so we have some triangles here just because, you know, we have to kind of fill kind of these weird areas, but predominantly, you know, we have mostly hexahedrons or bricks. Okay.
Professor?
Yeah. What's up?
When you did the automatic method, did you does suppressed matter at all? It said no, but okay. So then you did hex dominant.
Right. Yeah. So the only thing I changed for the method was just the shape, which is the method, and then the element order, which is I changed to quadratic. Yeah.
Element order. Okay. Awesome. Thank you, Professor.
Yep. Mm-hmm. Yep. And so you can see from the mesh here that it's much more fine. Okay. You know, this will lead to a much more accurate simulation because we have, you know, more elements. And just like we did before, we can check the statistics. And so we can click mesh right here. And we can click on statistics. And you can see that here that we have 1,300, almost 1,400 elements and about 5,300 nodes. Okay, and so still relatively coarse, relatively speaking, but this is a much more this is a much better looking mesh. Okay, all right, and so that's everything with the mesh. And so now we're going to apply the question. What's up?
Oh, one last thing. Can you go to body sizing? Because when I type in 0.5 centimeters, it's just defaults to millimeters.
Yeah. Oh, so you probably you're gonna have to change the units up here. So if you remember from the first activity, you can change the units, and so you can pick whichever unit system that you feel most comfortable with. And so for this one, I just picked centimeters just because it kind of matches up well with that.
Oh, okay.
But you can even do this in like inches and feet if you really want to. So you can if you want to change the units, you can do it from this menu up here.
Okay, so then do 0.5 centimeters, and then that's it.
Yeah.
Okay.
Yeah. Mm-hmm. Okay. And so the next thing that I want to do here is to apply the boundary conditions. Okay. And so for this part, I'm going to leave it up to you guys. And so because part of the the challenge of running finite element simulations is first of all getting the program to work, which is not trivial as you guys are experiencing. But the other challenging part for applying finite elements is specifying your boundary conditions. Okay? And so for the first activity and for all the problems that we've been kind of hand doing in class, I've been giving you what boundary conditions to apply on those situations, right? So I've been telling you basically where it needs to be fixed, where to apply your loads, the magnitudes of the loads, and all that stuff. Okay. And so for this activity, I want you guys to determine that yourself. Okay. Because what you're going to be doing in practice is no one's going to be feeding you a perfect kind of finite element problem where it said mesh to this size, apply this boundary condition here, and then get the results. What's more realistic is that your manager's probably going to come to you and say we have this kind of physical situation, so we have this part that's either in operation or we want to design this one, and we want to see whether whether this part can kind of hold up to all these loads. Okay? And so they're not going to tell you explicitly what boundary conditions that you're going to apply. And so, for this activity, I want you guys to kind of determine what those boundary conditions are. Okay. And so to do that, let me kind of describe to you kind of the physical situation that we're going to be faced with. And so let me unsuppress these just for now. Okay. Right. And so just like I mentioned, earlier, this part right here is basically a bike crank. So I think, everyone's kind of seen a bicycle kind of in action, right? And so what's going to happen is that this part over here, with the 3 holes, this is the part that, attaches to your bike, right? And then this part on the other side, this is the part where someone actually pushes down with their foot to kind of, propel the bike forward. Okay. And so the situation that, that you're going to be simulating is, you're part of the design team for this bike, and this is the crank that your design team has kind of pushed forward, right? And so what your manager wants to know is that if the crank is designed as is like this, and someone pushes down onto the bike crank with their foot on this side, is this bike crank going to hold up, or is it just going to snap in half, right? And so and so to do that, you need to consider where you need to ask yourself, where is this bike crank going to be attached to something major, and where are the loads going to be applied? Okay. Okay. So let me go ahead and suppress these guys again.
So is this similar to like when you run an FEA on SolidWorks and you make your fixed and roll, positions?
Yep. Nope. That's it. That's exactly it. So you're basically going to be doing this here. Right?
Okay.
And so I'll give you some hints though. And so, I want you to apply 2 boundary conditions here. And so at the very least, you need to have a fixed support somewhere, right? And I'll let you decide, where the best place to apply a fixed support is. And then the other thing I want you to apply is a force, okay? And that force is going to mimic, the force of someone pushing down on their bike crank with their foot, okay? And so I'll give you the magnitude of the force. And so let me switch to pound force here, okay? And so the magnitude of this force is going to be 100 pounds, okay? And that's going to be applied somewhere on this model, and it's going to be applied in a certain direction, okay? And actually, let me do it like this. So if you
Sorry, I have a question about that. I haven't looked at the actual assignment PDF yet to see what we need to submit, but isn't the also direction dependent on at what point the crank is at? Because if that crank is all the way down, it's going to be pushing along linearly along the entire thing.
Yeah. No, that's a great question.
If it's in the position it's in right now, it's going to be pointing down, like on the, I guess, the negative y side of it. You know what I'm trying to say?
Right. No, yeah, that's a great point. And that's definitely a good consideration too. Because when you're doing these simulations, is you want to think about what's the situation, or how are these things going to actually be applied in practice. And so for this particular activity, I want you to look at kind of the worst case scenario. And so what loading condition will basically result in the most stresses along the bike crank. But actually, the beautiful thing about finite elements is you can actually try both. And so you can actually try, say that this bike rack is kind of vertically upwards like this, right? And someone's pushing kind of vertically down right here. And so you can actually apply the force kind of vertically down like this and see what the stresses that result. On the other hand, if the bike crank was horizontal and someone was kind of pushing down vertically like this in the y direction, what kind of stresses would result from there too. So, I would encourage you to try both and see, what that leads to. Because the beautiful thing about finite elements is that, it's very easy to change these boundary conditions and to change the directions and things like that. Because that's the whole point. That's the whole point of, doing these things in a computer, because the computer can simulate these things really quickly. And so, definitely try out different loading conditions and see, what leads to the most stresses. And to kind of, help you apply in different directions, if you remember from our first activity, we can change this setting here for the force, right? And so when we have force selected here, kind of the default version of this is in vector form. And so that, basically, will basically apply the force kind of perpendicular to that surface. But what I find to be more helpful for these kind of situations is to define the force in terms of components, right? And so you're going to change this setting here by define by, but instead of vector, you're going to click components, and you can individually select, choose the X, Y, Z components of the force. Okay? And so the only thing I tell you in the ANSYS activity is that the magnitude of the force has to be 100 pounds. Okay. And so if I want to apply a force in the X direction to kind of pull it this way, I would make the X component 100. Okay. But then if I want to apply the force in the Y direction, then I would apply 100 like that. Okay? And this is for a force that goes kind of vertically upwards like this, because it's positive 100. But if we want to make it in the negative direction, we can go minus 100, and then that will point the force downward like that. Okay. You can even do. Oh, go ahead.
Where do you suggest that we apply the force? Because I know we can select multiple faces by just holding Control. Do you just suggest the two inner rings?
Yeah, so I'll leave that up to you. So that's part of the activity of where exactly you want to apply the force. And so remember, we don't have the pedal here, and so you can't apply it on the pedal. Oh, sorry. Oh, okay. And so we don't have the pedal here, so you can't apply that on that rod. But we have the part where the pedal actually attaches to. So if you kind of imagine in practice, the force that you're going to apply on that pedal is going to be transmitted through this crank, and it's going to be applied somewhere over here. Okay. And so, I've already kind of given you a lot of hints about where you should apply this force. But the exact surface and the exact direction, I'll leave that up to you guys. Okay.
Last one more hint. When we do run the analysis, do you recommend that we do it with the pedal?
No, so keep the pedal suppressed, and
okay.
so
this part itself.
Right. So for this activity, since it's kind of our first time doing a 3D simulation, I want to keep it to just one part, because when you start to include several different parts, or you have to define how those parts are going to connect and interact. And so that's the subject of the next activity. So in 2 weeks we'll do an assembly, and we'll see how to mate different parts basically. But for this one, stick to just one part. Yeah.
Okay. And then this activity is due a week from today.
I pushed it back a little bit because homework 2 is due next Friday, and so I think I pushed this back to the following Tuesday. So I think it's Tuesday, March 16th. This is due.
Okay, cool.
Yep.
Thank you.
Okay. And so before, if you were able to install ANSYS in this time, maybe you've already applied the boundary conditions. And so the other things that you need to do is you need to specify which output fields that you want to look at, right? And so for this activity, the ones that are probably going to be most useful to you is one is going to be total deformation. And so that's going to show you how much the bike crank is going to be deforming. And then the other thing is the stress. And so you can either pick equivalent stress or maximum principal stress. Usually I pick equivalent stress just because to me, that's a little bit easier to visualize what's going on. But in this activity too, because I know that there were some questions about, what's the difference between equivalent stress and maximum principal stress. In this activity, I basically gave a little bit of an explanation of the difference between them. But, but for completing the activity and answering the questions, you can just choose one or the other. So I would suggest equivalent stress if you're, if you're not sure which one to pick. Yeah. Mm-hmm. Yeah, so question in the chat. So should we add a finer mesh at the holes like the last activity? So I'll leave that up to you guys too. And so, if you think that you need some mesh refinement around the holes, try it with the mesh refinement and try it without it and see how it affects your results. But you guys, we learned how to do mesh refinement last time, so definitely try it out and see how it affects your results. Okay. Okay, so we do have some time left. So we do have about, maybe 23 minutes. And so I know some people were having some issues. So I'm going to take this time to kind of, visit people kind of individually and see if I can help them work through it. But, for those of you who were able to follow along, that's basically it for this activity. So, again, we're building a lot on what we did on the first activity, but now I'm kind of letting you decide, what you want to do with the mesh and also decide what you want to do with the boundary conditions too. Okay. All right, so any final questions before I go and try to debug people's issues individually?
When will this lecture be posted up so that we can like the people that need to reinstall it?
Tonight. So it'll be so I'll process. I'll start uploading basically as soon as it's processed. So I'll start uploading probably around like 5:30 because it usually after the lecture Zoom usually takes like 15-20 minutes to process. I don't know what that means. And then there I'll upload it onto YouTube, and I'll put the link on there. So it should be up before dinner. Yeah.
Okay, thank you. Appreciate it.
Yep.
So here's a question. Like you said, it's like up to us or something to figure out what mesh sizes we should be using, right?
Yep. Mm-hmm.
But what basis should we be using for like figuring that out? Like it wouldn't be a good thing for it to just be like guessing what mesh size would work well or something.
Yeah, no, that's a great question because we haven't really discussed about what makes a good mesh. And so far the only thing that I've kind of told you about the mesh is that before the automatic mesh there were far too few elements, so it looked pretty coarse. And so if you think of your mesh kind of like a computer image, right? So basically the more elements that you have, the more pixels that you have, the more accurate your simulation is going to tend to be. And so, that's kind of like a qualitative way to kind of describe that. But what you would actually do in practice is you would, start out with a coarse mesh. You would run your simulation. You would see that what you would get for like the deformations and the displacements. And then what you would do from there is you would refine your mesh. And so, you would make your mesh size smaller, rerun your simulation, and then check to see if your results changed. And so if your results change, that means your simulation isn't accurate enough yet, and you should keep, refining your mesh. But if your results didn't change when you refined your mesh, that means your mesh is already kind of good enough. And so there's this idea in finite elements of convergence, whereas, your mesh needs to be fine enough in order to capture all the results that you want to capture. And unfortunately, there's no test that you can do beforehand to know what that looks like. Eventually you run enough of these simulations, you can kind of visually look at a mesh and say, I think that's going to be too coarse. But for now, for this kind of simple problem, I think, you can choose, almost anything as long as you don't have just like 4 elements across the bike crank. I think any mesh that you choose will be okay. But again, that's going to be a subject for a future lecture too. So that whole process of, refining your mesh and running your simulation. So that's called a mesh convergence test. And so we'll definitely go over that, a lot more later on in the class too. But for this activity, choose what you think, would give you kind of a refined image. Yeah.
Okay.
Mm-hmm.
Okay.
Yep. Okay. All right, and so who's still having some issues with their ANSYS? Besides having to reinstall it, because I think Jacob, earlier you were having an issue where you weren't seeing the material properties, correct?
Yeah, I decided to reinstall because it's not even have any luck. So
okay,
no
okay,
worries.
okay. Yeah, if you reinstall, and then if it's still not working, just let me know, and then I can help you out with that. All right. Anyone else having some issues with their ANSYS? Anything?
Dr. Tran, we should be able to get through this entire ANSYS activity just by following the PDF, right?
Yeah. So the PD. So what I did just now was I basically just kind of read the PDF. So I have it kind of in front of me with my iPad. So and so yeah, everything is in the PDF. So you should be able to follow the PDF and be able to do everything as well.
Perfect. Thank you.
Mm-hmm.
Professor?
Yep. What's up?
So when I was going to download, it says the built-in license is valid until 3/31.
Again.
21.
Uh-huh.
When I
really?
do it,
even when you download the student one, it is still.
I tried clicking the student one and then it wouldn't pop up that thing. So
That's really weird.
I'll try again, but it was saying it was only valid for like a month.
Okay.
So maybe I was clicking like the trial version. Let me look it up again.
Okay. It seems like a lot of people are having that too, because it looks like Ben was also saying it's only valid until 3/22. Huh. That's so weird, because I literally downloaded it today and then I didn't get that at all. I don't know if I have an account with ANSYS or something. I'm not logged in, I don't think. Let me share my screen again.
Yeah, I'm looking. Okay, so I'm at the one that you showed.
Yeah.
Oh, okay. See, yeah, this one says 3/31/22. The other one that I was on was 21.
Okay. Yeah, hopefully, yeah. Definitely choose the one that says 22, because I think we'll definitely be done with the class before 2022. But yeah, how strange, because I've honestly never seen that before. I can show you the one that this is the folder that I downloaded today. And so it should download like a huge zip file for you. And so it should say, ANSYS Academic Student 2021 R1 Windows X64. So yeah, that's really strange.
So after you download that file, what do you go to? Do you go to setup?
Yeah. So if you open up that zip folder and then you go to setup down here, and then that will install ANSYS. And it kind of takes a while. So I kind of started it as I was eating lunch, and it kind of finished about an hour later. So it does take quite a bit of time. Okay. Oh, actually, I do see it right here. Yeah, built-in license valid until 3/31/2022. I just clicked agree. That shows how careful I am with.
Yeah, I just clicked it.
Okay. Yeah, it should. If it's gonna last until about a year from now, that should be good. Yeah.
And then I have another question. When is our exam again? Is that next week?
No, it's gonna be. It's going to be Tuesday of week 8. And so if we go back to over here.
That's 2 weeks.
Yeah, so 2 weeks. Mm-hmm.
Got
yes.
you.
Yeah, so next week we're going to cover, more probably finite element forms that need to update this. And then the exam is going to be the following week. Yeah, so week 8, we're going to do another ANSYS activity, and then we're going to take the midterm.
And that midterm one stops after week 4 for like the.
I think it stopped after week 5. So last thing that we did that's going to be on the first midterm is beam equations.
Yeah.
So it's basically going to be homework 1, 2, and 3.
Perfect.
Mm-hmm.
Thank you.
Yep.
One more question about the homework, or not the homework, the ANSYS activity.
Yeah. Mm-hmm.
It looks a little more extensive than the last ANSYS activity.
Mm-hmm.
Is it?
In terms of the number of simulations that you run, it's about the same. But there is more like stuff that you kind of have to explain. And so if you look at like problem 5 on this activity, you know, I'll kind of spoil it a little bit. So if you apply the load vertically, what you should see is that, you know, the bike crank is not going to yield, and so it's going to be underneath the yield strength.
Well, I'm trying to figure out in terms of time management whether I'm going to be spending more time on this one than the last one.
I see. It should be about the same amount of time.
Okay. Thank you.
Mm-hmm.
Currently, some people in the chat are saying that their license for 322 is supposed to be for the year 2022, not March 22nd of this year.
Yeah. So yeah, if it's until 2022, then we're good. And that should take us till the end of the class. Yeah, maybe we just downloaded at a weird time, which was where that year was ending, and then this is kind of a new year for that. So yeah, hopefully this will be fine until the end of the class. Right. And so if you're downloading ANSYS, or if you're installing it, and you know, if you have no more questions, then that's all I kind of had planned for today. So thank you guys for tuning in. You know, hopefully you know, future activities will go a little bit smoother once everyone downloads the you know, the most current version. But thank you guys for tuning in. Thank you guys for your patience. Have a great weekend, and I'll see you next week. Yeah, I'll stick around until, you know, 5:15. You know, if you want to ask any more questions. But you know, I have nothing more planned. So if you got to go, then you can definitely go ahead.
Thank you.
Yeah. Thanks, guys.
Professor?
Yep.
How do you create a parasolid in SolidWorks?
Um,
Is it just save as and then you pick the file type, or is it a
yeah.
separate process? Oh, okay.
Yeah, you click save as, and then I think.
And what kind of geometry is a parasolid? Because I know that like STLs is all the triangles and the step files is solid, but what is
that's a good question. I used to know this because I used to work with parasolid files when in graduate school. That was a long time ago. I think parasolid is it's parametrically defined, and so what that means is that it kind of defines it as kind of like a surface function. If I'm not mistaken.
So they're approximating an exact solution.
I believe so, but
so you could get theoretically every point on your surface instead of like losing any accuracy.
Yes.
Oh, that's cool.
Mm-hmm.
Okay.
Are we good to head out, Professor, if we're done?
Yep.
Awesome. Thank you.
Yep. Have a good weekend.
You too.
Thank you, Dr. Tran. See you next class.
Okay, see you next class.